Good day to you everyone, my name is Enkoni with metric number S42710 and I would like to present to you my final year project with title of Titanium Dioxide and Zinc Oxide Sol-Gel Coated Clear Bits in Photocatalytic Reactors. And this research has been done under the supervision of my supervisor, Dr. Wan Salida. For the introductions, based on the effluent compositions and the discharge volume, wastewater that produced by textile industry have been rated as one of the most polluted from all the industrial sectors. And for the problem statements, powder conditions of photocatalysts such as titanium dioxide and zinc oxide will be difficult to recycle, and while sol-gel coated photocatalysts will be more easy to be harvested back. Hence, the aim of this research is to characterize and evaluate the photocatalytic performance of titanium dioxide and zinc oxide coated on clear bits. The first objective of this research is to investigate the effect of varying titanium dioxide and zinc oxide ratio on photocatalytic properties of the prepared titanium dioxide and zinc oxide bits. Second, to determine the effect of titanium dioxide and zinc oxide coated on clear bits on recycling. While the methodology in this research firstly is the material selections, and the material being selected is photocatalysts are titanium dioxide and zinc oxide, and dimethylene blue, and also the supporting material clear bits. Next will be the sol-gel preparations of the titanium dioxide and zinc oxide, and the titanium dioxide and zinc oxide being sol-gel coated on the clear bits for the clear bits preparations, and photoreactor setup have been done for the experiment to be carried out. And this photo and the figure show the photoreactor setup in the experiment. Lastly, after the experiment being carried out is the analytic techniques. Well, this is the result for my research. Firstly, this graph shows the relative concentrations of methylene blue versus time for the titanium dioxide with different weight load of zinc oxide, which from 0 to 5 gram. And from the graph, you can see that the 5 gram of zinc oxide show the best degradation effect on the methylene blue. And the following graph are the repeating experiments of titanium dioxide with different weight load of zinc oxides for 5 repeating experiments. And that includes titanium dioxide with 0 gram of zinc oxide, with 1 gram of zinc oxide, 2 gram of zinc oxide, 3 gram of zinc oxide, 4 gram of zinc oxide, and also 5 gram of zinc oxide. And from the result in all this graph, we can see that the clear bits that have been harvested back will show almost the same degradation effect with the first experiment. And for the experiments for titanium dioxide with 5 gram of zinc oxide also show the greatest degradations of methylene blue concentrations, which come to relative concentrations of 0.06, that same as 94% of dye removal. For the discussions, comparing with the research by Ong and others 2012 in the photodegradation conversion dye of methylene blue that only use immobilized titanium dioxide, the time taken in this study to degrade the methylene blue is much more shorter. And also, this study showed that using clear bits as the supporting material for sol-gel titanium dioxide and zinc oxide worked as well as the other research that used glass by Gallagher and others 2004, and ceramic particles by Kenke and L and others 2005 as the supporting material for the photocatalyst. In conclusions, the first objective of the study had been figured out. The result of titanium dioxide and 5 gram of zinc oxide had the best performance on the methylene blue degradations. Besides, the second objective also achieved as the titanium dioxide and zinc oxide sol-gel coated clear bits have a better recyclability than the powder form of titanium dioxide and zinc oxide. Hence, the study proved that titanium dioxide and zinc oxide coated clear bits show positive outcome on methylene blue degradations, and it can be further applied in the industrial effluents treatment. And these are the references in my slide presentations. Thank you so much for watching.